Unit 5, Day 6. In many ways, this lesson is review. You will just see a few small differences than what you already know. First of all, we are not going to be on the unit circle, so the hypotenuse or radius is not 1 anymore, but some general r. But things don't change. Sine is still opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And these guys are still the reciprocals. Cosecant for sine, secant for cosine, and cotangent for tangent. And so the only difference, like we said, is that the hypotenuse or radius is not going to be 1, but we have the Pythagorean theorem. So in A, if we know that x is -3 and y is -5, we're in the third quadrant. Here's our triangle, and the hypotenuse, a squared plus b squared equals c squared, or that's c squared, so c period is root 34. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, or y over x. By the way, the hypotenuse or radius is always going to be positive. And then our reciprocals again, cosecant for sine, secant for cosine, and cotangent for tangent. You go ahead and do B using this diagram. Check your answers, see if they match what I have. I try to almost always draw the diagram as best I can. Tangent is negative. Please note that that could be in the second or fourth quadrants. Be careful. Cosine is greater than 0 or positive. That's in the first and fourth quadrant. That's when x is positive, and so I must be in the fourth quadrant. Tangent is y over x, and since I'm in the fourth quadrant, y has to be negative, x has to be positive. Once I have these two ingredients, I can use the Pythagorean theorem to find the hypotenuse. A squared plus b squared equals c squared. If c is 13, c squared is 13, c then has to be root 13. Like I said, c is always positive. Hypotenuse is always positive. Sine is y over r. Cosine is x over r. Tangent is y over x, or opposite over hypotenuse, same. Opposite over adjacent, same thing. And then I still have the reciprocals. You do the same thing for B. Can you figure out why it's in the third quadrant, given this information? Now, we saw earlier that, for example, if I take this angle, sine is opposite over hypotenuse, and if I take this angle, sine is the same opposite over the same hypotenuse. And if I take this angle, or this angle, or this angle, they're coterminal, and so the opposite, or the y, and the r don't change. The same is true for this angle. I can go around and around and around, and nothing changes. So it starts over every 360 or 2 pi. So sine of any angle is the same as sine of any angle plus 2 pi. Same with cosine. We know that this angle has an x and OR. This angle down here has the same x and R. And so if I do this and this, I get the same cosine. Same here. If I do this and this and this, I get the same cosine. So cosine is the same no matter how many 2 pi's I add. I can add 2 pi and 2 pi and 2 pi. Now tangent is a little different. This y over x matches this y over x. So you're right, these are positive and these are negative, but if I take y over x, positive over positive, or y over x, negative over negative, they're both positive, which means these start over every pi. That's why tangent starts over after pi. If I have a negative tangent and I add 180 or pi, I get the same tangent, because here y is negative, x is positive. Here, y is positive, x is negative, and here y is negative, x is positive. Negative over positive, or positive over negative, it's still going to be negative, and so these start over again every pi. So tangent and cotangent have a period of pi. And tangent and cotangent match up, sine and cosecant match up, and cosine and secant match up in terms of their period, in terms of how long it takes for it to start over.